as we're going through, it seems familiar to you. We can do as many or as few examples as you need, so you just kind of need to let me know as we go through if you need extras or if you're ready to move on to the next thing. So, what is a piecewise function? Do you know what I'm talking about when I say a piecewise? What's a piecewise? Okay, you have multiple pieces to it, so it's defined differently. On different parts of the domain. So let's look at this one. This one has two different pieces. F of x equals 2x plus 4 if x is less than 1, and f of x equals 4 minus x if x is greater than or equal to 1. So when I graph this, I'm going to need two t-charts. For the first one, what x value do you have to plug in first? We're going to do 0. We have to start at 1 and then things less than 1, so maybe 0 and negative 1. Now, your x's have to be less than 1, so I can't technically plot 1, but I need to for my starting point. How am I going to note that on my graph? Open circle. Alright, so then if I plug these in, 2x minus 4, so 2 times 1 plus 4, gives me 6. 2 times 0 plus 4 is 4. 2 times negative 1 plus 4 is 2. So 1, 6 is open. 0, 4, negative 1, 2. So when I graph this, does my line extend both ways? No. Which way is it going? So it only works when my x's are less than 1. That open circle is my starting point, and it continues this way. The second piece is for when x is greater than or equal to 1. So in your t-chart, you're going to again start with 1, but this time it had to equal 2, so it will be closed. And then we need things bigger than 1, so maybe a 2 and a 3. So 4 minus 1 would be 3. 4 minus 2 is 2. 4 minus 3 is 1. We've got 1, 3, 2, 2, 3, 1. So it's going to look like that. Domain and range. Domain. Quick check at the end, just a suggestion, to make sure you did this correctly. These are functions, so they should pass the vertical line test. That'll help catch it if you draw your lines going in the wrong direction. That also takes care of, we have to have an open and a closed here, so it passes the vertical line test. What's my domain? What x values do we use here? So I'm going to write negative infinity to positive infinity. My range, my y's, you have to go from the bottom up. So these are going down forever, so it's coming from negative infinity, and where does it stop? 6, it was open, so it gets a print. Do you guys remember doing these before?
Yeah.
Good. We're going to graph at least 2 more, and more after that if needed. So we'll do a minimum of 3 together. B. need our two t-charts. What's the first thing we have to plug in? 0, and then things less than that. Would this one be open or closed? Closed because of the equal to. Okay? So opposite of 0 is 0, minus 2 is negative 2. Opposite of negative 1 would be 1, minus 2, negative 1. Opposite of negative 2 would be 2, minus 2 is 0. So I'm going to plot those. So 0, negative 2 was my starting point. Negative 1, negative 1, negative 2, 0. So from my starting point, this was x less than. We're going to extend to the left. Second one, what do we plug in first? 0. It will be open because it didn't have an equal to, and then we need things greater, so it may be a 1 and a 2. So if you put in 0, 0 times a half minus 2 would be negative 2. 1 half times 1 would be a half, minus 2 is negative 1.5. Put in 2, we get negative 1. So 0, negative 2. It says open, but when I go to graph it, I already have a closed circle there. What happens if you have an open and a closed at the same spot? It's just closed. Okay, 1, negative 1.5, 2, negative 2. So it would look like that. What's our domain on this one? Okay, positive fitting again. What is your range on this one? Get everything from negative 2 up. Questions there? Alright. How is this overall? Good, bad? Let's do at least one more together. Okay. So go ahead and write down your function. So how many t-charts do I need on this one? 3. We have 3 different pieces. So the first one. So look at that. I have 2 endpoints here. That's a little different than the previous ones. What does that mean? Right, we have to include those 2. And then you could do something else in between if you wanted. So if I put in negative 3, opposite of negative 3 would be 3, plus 1 is 4. If I put in a 0, we get out 1. If you put in 1, you get 0. Are either of those open? One is going to be open. Okay, so if I go to plot this, negative 3, 4, 0, 1, 1, 0 is open. Do I extend my line either direction here? No, we have 2 endpoints. That means your graph is just a segment. It's only between those 2. 2 if x equals 1. When I make my t-chart, what x values can you use? Only 1, and what do you get out? 2. So 1, 2 is just a point on my graph, and that's all that piece represents. The third one, what are we going to plug in first? 1, and then we want things greater than that. So maybe like 2 and 3. So 1 squared would be 1. Open or closed? Open. 2 squared is 4. 3 squared is 9. So 1 is open. 2 4. 3 9. So I'm getting this portion of a parabola. And it keeps going to the right because it's for all x's greater than 1. Are you guys okay with that graph? Quick check, is it a function? Did it pass the vertical line test? Yeah, so use that to make sure you graphed yours correctly. Now let's answer all the other questions I asked. So A, find f of 0, f of 1, and f of 2. When I ask you to evaluate those, you have a couple options. You could graph it and look at the graph, or you could just look. If I have an x value of 0, 0 fits which of these three requirements? The first one, 0 is in between -3 and 1. So you're going to plug it into this first part. So opposite of 0 plus 1 is 1. F of 1. If x is 1, which of the three pieces are you using?
2.
Second one. X equals 1 is the second one. So if you put in 1, you get out 2. F of 2. When my x is 2, which of the three rules? The second one only works when x equals 1. 2 is greater than 1. So if I plug it in here, 2 squared is 4. So when you're evaluating like that, you're only going to get one answer out. It's a function, so you can't get two answers. You just have to decide which of the rules it applies to. Is that okay with everyone? Domain and range. Domain of this graph starts at -3. So I can tell it's fading. In the past, we didn't have any in stock. Yeah, in the past, we didn't have any stock. They're struggling to ask for that. I don't know the last time it was replaced, but we never had it. And if you need to look at that, I can. Thank you. So my domain, it starts at -3. This black piece ended when my x is 1, but that purple dot fills in and then it continues forever. So it'd be 3 to infinity. The range, what's our lowest value? 0, but it's open, so it'd be a parenthesis. What's our highest? So there's domain and range. The other question I asked, is this continuous? No. Continuous means you can graph the whole thing without picking up your pencil, and we can't do that here, so it is not a continuous function. Questions on this one? I want to give you guys a problem, just like this first part here. I just want to see if you can evaluate some piecewise. So you do not have to graph, you just have to evaluate those pieces. When I say f of 0, that's saying my x is 0. If x is 0, which of these three rules apply? First one. 0 is bigger than -2. So you're going to plug it into that first piece. So you get 0 minus 1, so -1. Okay, 2.1. That's saying our x is negative 2.1. So looking here, if x is negative 2.1, which rule applies? Third one. Negative 2.1 is less than negative 2. So we're going to plug it in there. And we get 12.3. C, this is saying my x is negative 2, so which rule applies? Second one. So negative 2 squared is 4. D, f of 3, that's saying your x is 3, so which rule applies? First. 3 is bigger than negative 2. Yeah, other questions? Alright, where are we at? Do we need more practice? You guys want time to work and ask questions?